Welcome to our C Sharp Programming for Beginners course. Whether you're completely new to programming or looking to expand your skills, this course is designed to guide you through the fundamentals and beyond. The course is structured into several modules, each focusing on key aspects of C Sharp programming. Module 1, set up your environment and get familiar with Visual Studio. Module 2, start programming with basic syntax and structure. Module 3, explore data types and variables. Module 4, working with strings and more. Module 5, use flow controls with if statements, loops, and other control structures. Module 6, using functions and methods to write reusable code. Module 7, learn object-oriented programming with classes, objects, and more. Module 8, handling and debugging errors. Module 9, File I/O. Along the way, you will also learn some finer tricks of the trade to make writing C-sharp code easier. Make sure to code along with the tutorials. Practice is key. Try out different things and experiment with the code. It's a great way to learn. Regular practice will help reinforce what you learn. Let's get started and happy learning. In this module, we'll dive into object-oriented programming. Objects are the backbone of C-sharp programming. Think of them as self-contained units of code that describe the properties and methods of that object. For example, a common everyday object is a car. It has properties that describe it, like make, model, and color. But it also has functionality, or methods. It can turn right or left, accelerate, and brake. The properties and methods are exposed to other objects in your program, while some variables and functions are private to the object. These may contain the inner workings of the object. In the car example, other objects don't really need to know the details of what happens in a car's engine and transmission to make it accelerate. Those are private methods. For other objects, the car object only exposes a public accelerate method. The great thing about objects is that once you've created a template of an object, you can create as many of those objects as you're like, and you only need to maintain their code in one place. In this module, we'll start by creating a new object class and define some properties of the object. We'll take a brief look at what the using statement is, then expend on the get and set statements in properties. We'll add some public and private methods and show a shorthand way to instantiate an object. Finally, we'll demonstrate using arrays of objects. We'll create a new project in our solution and set it as the startup project. If you prefer, you can continue on an existing project or create a new solution. Please refer back to Module 1 for the detailed steps on how to create a project. Let's create our first object. We'll create a new folder in our project to hold our custom objects. This is not a rule, but helps you keep things organized. Right-click the project name and select Add, New Folder. We'll call it Logic for application logic. Then, to add a new object, we right-click our new logic folder and select Add Class. A class is a template of what our object should look like. Inside the template, we'll define all the object's properties, methods, etc. We'll call our class Student. It will represent a single student object. To start with, we'll give our student class 3 string properties. Properties are variables of the object that will be visible to other objects. As you can see, we declare them as public so other objects can see them. As a convention, property names use Pascal casing, and their first letter should be an uppercase letter. Following the name is a get and set statement in the curly block brackets. We'll explain these in a moment. For now, let's go back to our program class and create a student object. This is called instantiating an object. Here we say, create a new object of type student and call it S1. Now when we type S1 and dot, a pop-up will show all public properties and methods of this object. Here we see our student number, first name, and last name properties we defined in the student class. We'll assign some values to them and use the object's properties in a write-line command. Perhaps you noticed that when we use the student class in our code, the IDE automatically added a using statement at the top of the code. It's a reference to the location where we defined the student class. In the student class, we can see its namespace now consists of the logic folder name as well. Above that are some using statements, but they're all grayed out because they're not used yet. C# uses using statements to include references to locations and libraries that contains code you use in your program. Say, for example, you included some third-party pre-written library to use in your app. You will include the using statement in the file that references that code. But the C# compiler is pretty smart. It will never include libraries in your code that you don't use. In fact, even if you only use one method in that library, it will only include the code into your app to run that one method. This is one of the aspects that makes C# code so compact and efficient. To clear the unwanted using statements, simply right-click on the class name and select Remove and Sort Usings. The IDE will clear all those unwanted using statements. Let's take a look at the properties in our student class. The first thing we can do, which is good programming practice, is to assign default values to these properties. So, whenever we create an instance of this object, it will already have some values in its properties. Now let's explain the get and set statements after the property name. They allow you to control how other objects are allowed to access these properties. The get means they can read the property value, and the set means they can set the value of the property. Here we remove the set statement, meaning other objects cannot assign a value to this property. Back in the main method, we see the editor gives an error when trying to assign a value to the student number value. Down in the error list, it says cannot assign to. This property is read only. These get and set statements have a formal structure. Say, for example, you wanted to format a property before returning its value to the code that's trying to get its value. We added a full name property, but this time we expand on the get statement. Here we say, if you're going to retrieve this property's value, return a string that combines the first name and last name. And of course, there's no set statement, so other code cannot directly set this property. Back in the main method, we use the full name property in the write-line method to display the student's full name. Back in our student class, let's demonstrate how to expand the set statement. We'll create an age property for this. First, we need a private variable in the class to hold the value of the property. Notice the underscore in the variable's name? This is customary but not required to name variables accessible to the entire class with a leading underscore. These are called class-level variables. Then we define a property called age, and in its get statement, we return the class level variable's value. But when some code tries to set its value, we use the special value keyword to assign whatever value is passed to this property to the class level property. Back in the main method, we assign some value to the age property and display it in the result. Just like any object, our student class can have methods. We'll define two methods. One will be public and can be called outside of the student class. The other is a private method and only visible to code inside the student class. Here we use the private access modifier in front of the getScores method to indicate this method is private and should not be visible to code outside of the class. However, private is already the default access modifier in C#, and we could have omitted the word private. When the public method showScores is called, it calls the class's private method getScores to generate 4 random int values. It then displays the scores to the console. In our main method, we call the student object's showScores method. In the main method of our program class on line 9, we create or instantiate a student object. This statement can be simplified. Because the compiler can already see that S1 will be a new student, you don't need to declare it as student, but simply use the keyword var. The var keyword says, I'll make S1 whatever you assign it to on the right side. Another way to simplify the declaration of S1 is to change the part where we assign values to its properties. Again, we can do this straight in the declaration. We create a block following the declaration, then assign values to the student object's properties, separating each assignment with a comma. Because this is one statement, the block is followed by a semicolon. This means we could have also written the declaration on one line like this. Let's look at another key component of a class, the constructor. The constructor is like a method, but it's only called when you create an instance of the class. The constructor will always have the name of the class, in this case, student, and it does not have a return type. That is because the constructor will always return an object of this type. Here we say, when you create an object of student, give me the student number, first name, and last name. It will use these arguments and assign them to the object's properties. But there's a problem. Back in the main method, where we instantiated a student object, we didn't pass any values in the parentheses. In line 9, the editor gives an error saying it couldn't find a constructor that takes 0 arguments. When you don't specify any constructors in the class, C# will generate a default constructor that takes 0 arguments. But now, since we've added a constructor, it assumes we don't want the default constructor. To fix this, we simply add another constructor that takes no arguments, and in this case, doesn't need to do anything in its code block. Now the editor is happy, and the error disappears. Back in the main method, let's make use of our new constructor. In line 11, we define another student object, and this time use the constructor we created that takes the student number, first name, and last name arguments. The second student object is exactly the same as the first. It used the class template of student to create another student. Both students have the same properties and methods defined in the student class, even though the specific values of their properties may differ. A fun analogy is to think of a class as a cookie cutter. We can use this student cookie cutter to create as many student cookies as we like. The great benefit, of course, is if we need to change the functionality of all these students, we only need to make the changes in the class, and all students will reflect the same changes. Let's display both students. Notice how we used the second student object's properties and methods in lines 16 and 17. The second student displays, but with an age of 0 because we never assign a value to it. You can either manually assign a value to it in code or add it as an argument in the constructor. For our last demonstration of objects, we'll create an array of objects. Just like we created arrays of ints and strings in previous modules, we can create arrays of objects. But first, in the student class's constructor, we'll add an age argument and assign its value to the age property. In the program class's main method, we'll create an array that holds 2 student objects. In lines 11 and 12, we instantiate the objects for index 0 and 1 in the students array. Then, we loop through the students array, displaying each student's detail and scores, with a blank line after each student. Thank you for watching this module of the C# Beginners tutorial. We hope it was informative and educational. Should any of the concepts not be fully clear, please go back to the relevant section and watch it again. To continue on the course, check out the links below in the description for the next module. Remember to click the like button and subscribe to our channel to stay up to date with the latest new content at Learn with James.